In lesson 4.4, we're going to work with the slope formula. In other words, so far what you have done is you have found the slope using a graph, right? You've determined from the graph how much rise and how much run there is between 2 points, put the rise over the run, and simplified if you could simplify it and you had the slope. What if we don't have the graph? What if we just have the ordered pairs, some of the ordered pairs that are on, that belong to that particular line? So, review. Slope of a line can be determined using any 2 points. It just takes 2 points on the line. Does it matter which 2 points we use? No, not at all. It does not matter because remember, slope is a constant rate of change, so it's between over any interval, that slope should be the same. And so we can use any 2 points on the line because it is a constant rate of change. So you can use 2 points, your neighbor can use a different 2 points from the same line, and you both should get the same slope. So what is slope again? Change in y over change in x. And that's one of the things that probably students mess up the most. We're so used to that x comes first in the ordered pair, and then it's followed by y. So in slope, we just like, okay, x's you guys be upstairs, y's you be downstairs, all will work out well. But it doesn't really work out like that. Slope has to be, and it should make sense that the steepness, which slope represents, steepness should make sense that, you know, you want to compare how much you go up or down versus how much you go over. So as you're climbing a hill, think about you're going up, and then in the process of going up, or maybe coming down a hill, in the process of that happening, you are also covering some distance, you're going over some. Okay, so there's a slope formula that you should have discovered in this lesson if you didn't know already before. What does little m stand for? It's the abbreviation for slope, isn't it? So what is the slope formula? Anybody know it? Jared?
y2 minus y1 over x2 minus x1.
Yeah, y sub 2 minus y sub 1. Well, what is y sub 2? What do they mean by that? And what's y sub 1? What do they mean by that? It's the y coordinate of one of the 2 points, isn't it? Yeah, so y sub 2 we could say is the y coordinate of the second point. Y sub 1 is the y coordinate of the first point. And then each of those points also have an x value, so the point that has a y value, y sub 2 value, is we're going to take the x from and call that x sub 2, and so we have our rise, our change in y, take one of the y's, subtract the other y. That's the same as counting on the graph. And then downstairs do the same thing with the x's, the run. So we really just have 2 points, and that's just a way to make notation for it. Each point has a y, each point has an x. Okay. Find the slope of the line that contains the 2 points. Ordered pair 5, -7, and 6, -4. So I've already said, you know what, I'm just going to let the first point that they gave us be x sub 1, y sub 1, and the other point, the second point, is going to be our x sub 2, y sub 2. And in other words, you have to decide where you're going to start. Which point are you going to be calling the x sub 2, y sub 2, because that's what the slope formula starts with. Do you think it's going to matter which point we start with? Which one gets called x sub 1, y sub 1, and which one gets called x sub 2, y sub 2? Think it's going to matter? No, why not? Did it matter counting on the graph? No, it didn't, did it? It didn't matter which point you started at. So it shouldn't matter here either. What's the really important thing is this. You have to make sure that both the rise, the subtracting of the rise, when you're getting the rise upstairs and the run downstairs, what you have to make sure is you start with the y value and the x value from the same point. That's what's really important. So we're going to start with -4, our y sub 2 value. We're going to subtract the y sub 1 value, which is -7. And notice that subtraction sign does not take the place of the negative in the 7. It's take the y sub 2 value, subtract the y sub 1 value. So what should I start with downstairs? 6. Subtract 5. Okay, so let's do our, simplifying that. Let's evaluate that. So this can really become -4. Let's change it to add the opposite. -4 plus what? 7. And downstairs, we probably really don't even need to change to add the opposite. We'll just do that one right away. 6 take away 5 is 1, right? Okay. Well then, what is -4 plus 7? 3 over 1. So we're basically saying, for every 3 units you go up, you go over 1 unit. For every 3 units you go down, do you still go over 1 unit? Yeah, but which direction this time? To the left, you have to go in the negative direction. So we can talk about it either way. So m equals, in this case, we are going to simplify this. What does m equal? 3. And we can write it our abbreviated way. Slope m is equal to 3. And get really used to that they call slope m, because we're going to use it a lot. Okay, any questions? Okay, why don't you go ahead and try that bottom one then on your own. And let's see if we all do the same slope. We're not going to say which point has to be x sub 1, y sub 1, and which one has to be x sub 2, y sub 2. You'll make that decision. What happened to you? Anything that happened to me? Yeah? And if you ended up with a -9 over 0, does that mean you're wrong? No. It's just that you just reversed the order of the points. You said the first point, -2, -2 is going to be x sub 2, y sub 2, and the other point was going to be your x sub 1, y sub 1. It does not matter which one gets to play that role, remember. So if you ended up with a -9 over 0, it's just because your points played the opposite roles that mine did. But what does this tell us? It's undefined. Can we divide by 0? Absolutely not. So we're going to say slope is undefined. This is a problem, having a 0 in the denominator. And we don't say slope is 0. Because is there a difference between having undefined slope and 0 slope? What kind of a line would this be on the graph?
Vertical.
A vertical line. If you said that the slope is 0, what kind of a line would it be? Horizontal. Okay, tell me something about the behavior of the other line, even though we don't have to graph it. Tell me about the behavior of the line from the first one we did when m was equal to 3. Positive. So what does that tell us about its behavior? It rises from left to right. Yeah. So again, we got to keep always making that connection too. So because you're not always just going to find the slope, or you're not always just going to graph it. Sometimes you're going to have to do both, and then you want to make sure that what you end up with makes sense. Okay. So any questions or concerns? I think both of these should have happened in your SQ3Rs. So you might want to compare and see how you did. Okay. Okay, let's go to the back side then. Find slope of a linear relationship given a table of ordered pairs. You get to pick, remember it said, you can use any 2 points on the line because there's a constant rate of change. So we get to pick any 2 ordered pairs we want. So who wants to make the call? What ordered pairs do you want to use? Courtney?
-2, 3, and 4, -6.
Okay, we're going to use the first one and the last one. Okay, so I'm going to let this one be, I'm going to have ordered pair -2, 3, and ordered pair 4, -6. Maybe we'll let this one, just for the fun of it, let this one be the x sub 2, y sub 2 this time, and this one will be the x sub 1, y sub 1, to show that it really does not matter which one's which, and then we'll find our slope. Okay, so the way I have them labeled here, I'm going to start with the 3, take away the negative 6, negative 2, take away the 4. So it's really a mathematical way of counting on a graph. We're finding how much difference there is between the 2 points vertically and horizontally. So this one can become 3 plus 6, and this one can become negative 2 plus negative 4. So we end up with a 9 for our rise, and we end up with a negative 6 for our run. Should we leave it like that?
No.
Okay. Well, first of all, we have a positive upstairs and negative downstairs. What does that tell us that the slope is going to be? Positive or negative?
Negative.
It's going to be negative slope because one of them is negative, and when you're dividing, a positive divided by a negative is a negative. And then do we want to divide 9 by 6 and get 1.3 repeating? Or actually, we wouldn't get 1.3 repeating, we get 1.5. Do we want to change it to its decimal name? No, typically we don't change slope to its decimal name unless they're asking us for a rate of change. And we have to put some labels on it. So in this case, we're just going to simplify it as a fraction. 3 over 2, yeah. So we're going to say the slope of this line is a negative 3/2. Okay, so tell me something about the behavior of this line. It's got a negative slope. What's that tell me about its behavior? I know there's such a thing as negative behavior, but that's only for people, not for lines. What does negative behavior of a line mean?
It goes down.
It goes down from left to right. Yeah, it's falling on the graph from left to right. Okay. Okay, now notice what I've picked from this next one. I've picked 2 ordered pairs, 2 different sets of ordered pairs out of that table, and I want us to do both of them. I want us to find what's the difference between, just randomly picking some points. So let's just all do them. Okay, so go ahead and work both of them. You get to pick which one's going to be your x sub 1, y sub 1 out of the pair that I've already chosen for you. I've already chosen the pair. You decide which one's going to be x sub 1, y sub 1, x sub 2, y sub 2. And then we're going to also try a different pair from that same line and see what happens. Because in the second pair of ordered pairs, there is a decimal y-coordinate. We end up with a decimal in our rise, don't we? Okay, now, can 13 over 2 be renamed as 6.5 over 1? What do you think?
Yes.
How?
Divide 13 by 2.
Divide 13 by 2, and what do you get? 6.5, don't you? Can 6.5 over 1 be simplified to 6.5? Yes. Okay, how about 6.5 over 1? Can it be renamed as 13 over 2?
Yes.
How? Multiply both of them by 2. So these really mean the same thing, don't they? This one we would say, should we simplify it? No, because nothing goes into both of them, so we would say, okay, let's leave it as 13 halves. This one we would say, you know what? I like to have it not in decimal form when I'm talking about slope, a constant change. So I can take both of these times 2, and I get 13 upstairs and 2 downstairs, and notice we have the same slope. That should happen all the time. When you get to pick any 2 points from the line, you better get the same slope as your neighbor who chose 2 other points. You both better get the same slope because it's the same line. It can't have a different slope. That would mean it has a different steepness. That would mean it might have a different direction it's going. What's the direction is this one going? What's its behavior? It's positive. Oh, you'd love to tell me about what kind of behavior it has. It's rising from left to right. Is it? What do you think? You think it's steep or not steep? 13 halves. It's rising 13, it's running 2. What do you think? Is it steep or not steep?
Steep.
Ah, yeah, if it's going up 13 and only over 2, up 13 and only over 2, that seems like it's going to be a pretty steep slope, isn't it? Okay, any questions? Okay, then let's go to the middle of page 256. And again, this is probably something you did in your SQ3R, but let's make sure you did it well. Okay, they have a graph there. It says the graph shows the height of a plant over a period of days. Find the slope of the line, then tell what the slope represents. Okay, well, if we're going to find the slope of that line, and let's do it with our slope formula. What should we use to help us do that then? 2 points. Okay, do we have to identify 2 points, or have they also already so nicely done it for us? Yeah, they've already so nicely done it for us. So all we have to do is write down those ordered pairs from that graph. And again, it doesn't matter which one gets to be first. They're both from the same line. Okay, tell me something. It's really important that we understand. We take time to look at this graph also and say, what are the x's and the y's representing? What are the x's representing? Days, the time in days. What are the y's representing? The height in centimeters. So remember, the y's go upstairs, so we should end, and the x's go downstairs, so we should end up with, what should our label end up being? Centimeters per day. Yeah, so if we were going to talk about the rate of change, which we, and when we do the slope for a problem, we know what the x and the y are representing. That's really what we're doing. We're describing the rate of change, and we can actually give it a label. Okay, let's go ahead and find that slope. M equals, I think I'll start with the first one. And if I start with the first one upstairs, I get to start with the first one downstairs. You get pretty smart at knowing when are you not going to have to deal with any negatives if you take a certain order. So I'm looking at the first order pair and say both the x and the y are larger than they are on the other one. Why don't I subtract in that direction? Because it does not matter. And 10 over 20 simplifies to 1/2. And remember that, what's the label upstairs? Centimeters. So 1 is representing a centimeter. And what's that 2 downstairs representing? Days. Why is that important? Because I think they asked us, they said, find the slope of the line. Well, we did. It's 1/2. And it's a positive 1/2, which is a good thing because the behavior of the line supports that. And then it says, then tell what the slope represents. Well, 1 centimeter over 2 days. So what is that really telling us? And we're going to write a sentence here. This is where we do our, show our English skills also. What is that slope telling us? Abby?
The plant grows 1 centimeter every 2 days.
Awesome. The plant grows 1 centimeter every 2 days. So in reality, how much is it growing every day? Yeah, 1/2 centimeter, 0.5 centimeter. Okay. So that would be another way we could state it, actually, too. That would not be incorrect. Okay, any questions? then you get to work on your homework practice for this.